Good morning, sir.
Good morning, Banu. Banu, can you keep the machines up?
Yes, sir.
Okay. And regarding MUFG, are you able to find a solution?
Yes, sir. We can modify the this one aux copy into a primary copy.
We can?
Yes, sir. We can. It's just an option, sir. I can show you.
Great. Okay, okay. So you just prepare a document on that so that we are
Okay.
ready. Hmm.
Hmm.
Hi, Mahesh, good morning.
కూర్చుంది ముసలామె ఆ
Good morning, everyone. We'll just wait for 1 or 2 minutes more and then we'll get started. Okay, let's get started. Anu, can you please share your screen? Okay, so just like yesterday, no need to log in. No need to log in. Just keep the machines powered on and we will use putty. Okay, that's the best and professional way of accessing the machines. Okay, so you all need to keep this in mind that you'll need to make a habit to use putty most of the time. Yeah, can you increase the font size? Change settings, change settings, change settings, yes. Appearance, yeah, great. So this is the Red Hat Linux machine. Similarly,
It's
this is the Proxmox machine, right?
Proxmox machine.
Okay. Okay. So maximize the screen. First, we'll work with one Linux machine 1.7 and then we will go and work with both the machines. Okay. Can you put them side by side or show the Linux machine first? That's the Linux machine, right? Okay. So
Left side is a Linux machine.
yes. So in the Linux machine, uh, we will learn certain tasks like how to check the health of the machine. So yesterday we have seen how to check the network related, slowness or how to reach another machine in the network or outside the network using a few basic network commands, right? So now we are going to see and check a few more things about the machine and then we will see how to work with multiple machines in the network. So first thing, if we check on the network, now we want to check on the hardware resources. Okay. So how to know what is the current CPU utilization, memory utilization of this particular machine? Okay. So the command that we need to run to do this is called as lshw. Okay. So can you type that command? lshw. lshw and press enter. Can you maximize this screen? Only the Linux putty screen. Yes. So go up, or is it still showing? If you see here, whole lot of information is being shown about the particular machine. Okay, whether it is virtual machine, whether it is physical machine, doesn't matter. Once the Linux kernel is installed on this particular machine, when you type lshw, it is going to show you everything about the machine. Okay, do a control C and do lshw pipe more.
LSHW.
lshw space
1 minute. It's not alone.
Okay, 1 minute. I'll take control. Allow me control. Okay. Right. So lshw space pipe and I more. Okay. So when we run this command, we will be able to see page by page. So first it is showing that what kind of a machine it is. We are seeing that it's a virtual machine created out of VMware. Okay. Then we see, the motherboard. It is an Intel chipset. Okay. We are getting that information. Okay. Then we see the date when this was installed. And then we see about the memory. Okay. So we see L1 cache, L2 cache, and L3 cache. Okay. These are all logical memory partitions. Okay. These are used by the operating system for various execution of various commands. And each memory cache has its own role to play with respect to the OS kernel. Okay. So as you see, the sizes of the cache, L1 cache is the lowest in size, 64 kilobytes. Okay. Then you see L2 cache, it is 256 kilobytes. Okay. Almost 4 times more than L1 cache. And then we see L3 cache, it's even more, it's 8 MB. Okay. So, and then the actual CPU RAM, that will be obviously in GBs, right? And if you see the physical ID, that's also, different. So what the OS kernel does is it uses each one of this cache for a different purpose. Okay. So we don't need to get into the details of it, but good to know. And then when we go down, we see more things about the CPU and how the various cores of the CPU. Now, what is a core in a CPU? So when you install a processor in on the motherboard of a machine, okay, whether it's a laptop, desktop, server, doesn't matter, okay, there are some things called as physical cores. Now, what is a physical core? The physical core itself, okay, is as good as a complete CPU, okay. So every physical core has the capability to run instructions by itself, okay. And all our software, be it the operating system, be it the hypervisor, okay, they will, when they are accessing the CPU, they are going to see how many cores are available to the various processes to execute the command, okay. Each core has the capability to process a particular instruction set, okay. And each core will have its own speed, its own memory, and its own instruction set. But at the same time, cores can also talk to each other to share instructions. So there will be another process which will manage jobs to the cores. So that's the overall architecture. Now, when virtualization was not there, that means almost about 30 years back, every physical core inside the CPU would be mapped as a logical core to the operating system. So one-to-one mapping would be there. So as many physical cores as you have in the CPU, that many cores you can see it in the operating system also. Okay. But after virtualization came in, okay, and we are able to install, hypervisors, then all these motherboard manufacturers and CPU manufacturers came up with a new technology called VT, okay, virtualization technology. You can enable something called as VT at the BIOS level. And once you enable VT at the BIOS level, each physical core can be represented or shown to the operating system as multiple logical cores. Okay. So sometimes the ratio is 1 is to 2, sometimes the ratio is 1 is to 4, sometimes the ratio is 1 is to 8, sometimes the ratio is 1 is to 16. It all depends upon how big and how capable the physical processor is and on what kind of a motherboard is that physical processor installed on. So depending upon that, this physical core to logical core mapping and extrapolation will be done. Okay. And that is what we see here. Once you install a hypervisor and you create a virtual machine on top of it, you are no longer talking about physical cores. Okay. Please remember this. Once you install a hypervisor on a machine and you are creating virtual machines or you are creating containers, you are no longer referring to the physical cores of the CPU or the processor. You're always referring to the logical cores of the CPU or processor, what it has been enabled at the BIOS level, and then by using the hypervisor like Proxmox or VMware or Hyper-V, what we have seen. Okay. And here what we see is only one CPU core has been enabled, to it. We can see the megahertz 2380 megahertz. Okay. And it's a 64-bit processor. Okay. We can see all that. And all the other logical cores or logical CPUs have been disabled for it. Okay, you see here CPU 1 is disabled, CPU 2 is disabled, and it is not able to show us any information about it. But in a live production environment, you will see that every virtual machine has been given multiple logical CPUs, or they call it vCPU, vCPU, virtual CPU. Okay. So this command helps us to see all that CPU information. So the bigger the processor, the more number of logical and vCPUs we can see in the system. Okay. So as we move forward, apart from these multiple CPUs and memory, there we see the memory slots. Okay. The memory slots, okay, are described as these DIMM slots. DIMM, DIMM. Okay. Now there are some calculations, okay, that are there to understand that if you have a certain processor, how many RAM slots you can populate, and what is the maximum RAM you can put per slot. Okay. And these are defined by the motherboard manufacturer and the hardware CPU manufacturer. Okay. So just because you have empty slots on that system doesn't mean that you can dump it with as much amount of physical RAM as possible. It will not work. Even if you dump it, the processor will not be use it and you will not be use it in the system. So that's a waste of money because RAM is one of the most costliest, hardware thing apart from the processor itself. It's extremely expensive. Okay. So you have to be very careful about choosing the amount of RAM per physical motherboard or per physical machine. Okay. And that is the reason why you will see that as and when you see a bigger processor, you will also see higher amount of RAM in that particular machine. These are correlated. There is a calculation, okay, that works. And that is what we are seeing here. Okay. That this there are and these slots are called as banks. You see here bank. The word bank is written. Bhanu, can you give me control, please? Yeah. You see bank is written here under the memory section. So that each bank is nothing but each slot, each memory slot. Now, just like how by using virtualization technology and hypervisors, we are able to extrapolate a physical processor and a physical core into logical vCPUs. Similarly, RAM also is capable of being logically provisioned. Okay. So whatever is the physical memory available, we can slice it and give portions of that RAM per virtual machine. And that is what we see here. Okay. That how much amount of logical memory has been given, and at the physical level, which slot has got how much amount of RAM inserted in that particular slot. So we can see all that information here using the lshw command. Okay. There is also another concept called memory ballooning. Okay. Which is over provisioning of memory. But in order to use that, you need a very fast, hard disk to support memory ballooning. Okay. So in our system here, we are not using memory ballooning. So only the amount of physical memory available, we are slicing it into logical slots per virtual machine. Okay. And that's what we see here. And it gives you a lot of information about which slot has got what. And then there is something called as PCI. Okay. Can anybody tell me what does PCI stand for? You can Google it, no problem. With respect to the hardware of a server or a laptop or a desktop, what does PCI stand for? Anyone? Come on. What does PCI stand for?
Peripheral component interconnect.
Yes, very good. Very good. Peripheral component interconnect. Now, what exactly is this? Okay. Peripheral. Peripheral means outside. Okay. Peripheral means outside. When apart from CPU and RAM, we also know that we need network and we need hard disks to be connected to the motherboard. Okay. These kind of components that get connected to the motherboard are called as peripheral components. Okay, they are called as peripheral components. Peripheral means outside, on the perimeter. We in geometry we understand circle. The edge of the circle is called a perimeter. So from there only the word peripheral has come. Okay, so anything that's on the outside apart from CPU and RAM, it's called as a peripheral component. And the best examples of peripheral components are networking ports, USB ports, okay, display ports, when we are connecting a monitor, okay, ports where we connect our mouse, ports where we connect our keyboard, ports where we connect hard disk, okay, all these are called peripheral ports, okay. Now, obviously, these ports have got some role to play with respect to how to use this complete system, right? We all know that. Like hard disk is used to store data permanently because RAM is a volatile memory. Once there is power loss, the entire data will be gone. And we have discussed a lot about different kinds of RAM in our data center basic class. So kindly refer back to that video. Then we know that we need networking ports, we need physical port, and sometimes in a laptop we need wireless port. So that's one more peripheral device. Then keyboard and mouse, these are peripheral devices. Then monitor, this is a peripheral device. Okay. Sometimes you may use a card reader, that's a peripheral device. Okay. So all these PCI peripheral devices are also listed in the LSHW command. Okay. So everything to do with the hardware layer of that particular machine, you will be able to see very detailed information about them by giving lshw command. Okay, the command is very simple. ls means list, hw hardware, list hardware, lshw. Okay, now suppose you don't want to see such detailed information. Okay, you want to see very concise information, then the command that we need to give is lshw space hyphen hyphen, okay, and press enter. Okay, short is, oh, only one hyphen, sorry. lshw space hyphen. So it will give a very brief information instead of a whole lot of detailed information, okay, about the hardware aspects of this particular machine. Okay, so we are seeing that that much information is not coming with LSHW in detail. We are getting very short information, okay, about the machine. Earlier we got a lot, now we are seeing very brief information, okay, like this. See, once again, it's scrolling up too much. Bhanu, can you just scroll a little bit to show the output of just the lshw short command? Yeah. Go up a little bit. Go up. Almost there. Yes, yes, yes. Yeah. Yeah. So you saw very short information. Okay. Only that much it is going to show. Fine. Thanks, Manu.
Mm.
Okay. Now we go to the next command. Okay. So I want to understand only about the CPU. Okay. So let me show you how to do that. We are currently in which directory? How will we know? We give pwd. Then if we want to go to the absolute root directory, we give cd backslash. Then when we say pwd present working directory, we get backslash. Okay. And I do ls minus al. I see all of these, right? Now you see there one folder is there called, one directory is there called proc. Okay. You see that one folder is there called as proc. This one. Okay. So this is the folder or directory where you have the information about the processor, the CPU. Okay. So what command actually helps us to see the information about the CPU? So cat, what does cat command do? Whatever is the content of that file, it will display the content of that file, right? So we inside the proc directory, there is a file called CPU info. Okay. We just type this command that show whatever is the content of this file CPU info and press enter. That's it. It will show you the various processors. Okay. And Bhanu, can you please scroll up a little bit? Yeah. Yeah. Below, come down. Yes. So you see there, genuine Intel CPU family, what is the processor name, what is the speed of the processor, 2.5 gigahertz. Okay. And then what is the cache given? We had seen earlier that we have L3 cache as 8 MB. That is displayed here. See, 8192 KB is nothing but 8 MB. Okay. So all that information is stored here and we can easily see that using CPU info. Just display whatever is there inside CPU info file and that is what we will see. Okay. Great. Now we will go to the next command. The next command is, now we want to see about the disks. Okay. So everything related to disks we will try to identify today. Okay. So just remember, most of the commands related to disks will start with D. It's very simple. Okay. So the first command that we can use to see about the hard disks or SSDs that are connected to this particular system is DU. Okay. DU stands for disk usage. Okay. DU stands for disk usage. But if you see, the disk usage command gives, a whole lot of information. Okay. And we always may not need so much of information. Okay. what it is basically showing is this particular file under this particular directory, okay, how much space is it storing or how much space is it occupying on the disk, okay? That is what it is displaying here. And all the subfolders and subdirectories, it will going to show everything, okay? Just like if you right click on C drive in Windows, go to properties, it is going to show everything, right? All the folders, all the subfolders, total amount, how much space it is used, all that it is going to show. So same thing, the du command in Linux is going to show disk usage, okay? But we need to always use du command with certain options so that we reduce the amount of output that we are getting, okay? So how do we see what are the options that are there with this command? Man, okay, man page. So I say man du, okay, and press enter. When I say man will give you the manual page, okay? And if you see here, it is going to show us estimate file space usage. That's the purpose of this command. And summarize the disk usage of the set of files recursively for all the directories. Recursively means under every subdirectory it will go and it will show. Okay. Then if you give minus all as option to this particular command, it will also tell that particular file or directory has been written or appended how many times. That means how many modifications have been done on that particular file. Okay. Then you can also see apparent size. Apparent size is basically used for sparse files. So we'll talk about that later. Then you can see something called as block size. Okay. Then minus C will give us total. Okay. And this is what we are going to use now. Okay. This option minus C or hyphen hyphen total. That is what we are going to use now. And when you use along with it minus h, small h, not capital H, okay, then you will see it in kilobytes, megabytes, and gigabytes, which is there in human readable format, not as bytes. Okay. So let us try this. So minus C and minus H. So I give du minus C, and when you have multiple options, you don't have to use minus two times. So you can give all the options next to each other. So, wait, du minus C. I pipe it to head. Okay, so like that. I will see only the top ones like this, right? I can also, instead of doing head, I can do top. Okay, and then do minus CH. It is showing in megabytes. 1 megabyte, 6 megabytes. Okay, like this. I want to see more. I can give 20 lines. So head minus 20. It will give 20 lines. So like that. Very simple. So then you will know which directory within the complete set of directories is actually taking the most amount of space in your hard disk. So as we see here, there are two directories under slash boot slash EFI that are taking 7 megabytes. So those are the largest ones right now. Okay. Any questions on this? On LSHW and DU disk usage? Very simple commands. Okay. There is nothing much you will have to do just see that information. That's it. Okay. Then there is one more command called df. Okay, df. So like du shows files and directories. Okay, df will show devices with file systems. Okay, df will show devices or disks with file systems on it. Okay, and it will also show that which particular device is mounted under which directory in the system, in the Linux OS kernel. Okay, for example, if you have a hard disk, if you have a USB drive, okay, now obviously the hard disk is going to have a separate file system and a separate directory structure for it, and the USB will have a separate file system and a separate directory structure for it, correct? Just like in Windows, right? Your hard disk will have C colon as its indicator, and when you put in a USB disk to it, you will see the USB disks being represented as E drive or F drive or some other letter. Similarly, in Unix or Linux, the internal hard disks of the system will be represented as a separate device, and the USB hard disks will be represented as a separate device. Now, which are those devices and what is the name of that device? You will see in the first column here, the first column. Okay. Then you will see the total size of that device as per 1K blocks, and how much is used, how much is available, what is the percentage used. And then in the end, you will see this particular hardware device, which is being showed in the first column, is mounted as under which directory, under root, the \root. Okay, when we do a man for this particular command called df, you will see file system disk space usage. That is what it shows. Okay, file system disk space usage, and these are all the various options. So you do -a, you get all. When you give -b, you can specify the block size. Again, -h, small h is in user human readable format. Okay. Then -i is inodes. We'll talk about inodes later. And when we do -l, then peripheral or external mounts are not going to be shown. Anything that is mounted from the network, that is not going to be shown. Only the local disks that are inserted into that system, only those are going to be shown, -l. Okay. So these are the various options that are there with df. So when I say df minus k, I'm sorry, df minus kh. Yeah. So now you see it will show in megs and gigs. Okay. So if anybody asks, okay, tell us what is the size of the hard disk that is inserted. Okay, you will be able to tell. Now, all these devices, right? The devices that are connected to the motherboard, the devices that are connected through PCI, they will all be represented as files in Unix or Linux. Okay. So which directory has all that information? That information is stored in this particular directory called dev. Okay, you see this directory, there is a default directory that is created in the Linux or Unix system. It is called dev. Dev stands for device. Okay, very simple. You want to know about devices, go into /dev. So let us try to do that. So the present working directory is root. So I will go into /dev, and here I do ls minus al. I will be able to see all the devices that are connected to this particular system. Okay, if you see here a CD-ROM drive, okay, that's a device. CPU is a device. Then disk is a device. Okay, like this. Then memory is a device. You see, all of these are devices that are connected to the system. Okay, even the keyboard that you connect will be a device. The mouse that you connect will be a device. Okay, all of that will be stored here. See, anything that is connected on the USB, that is also a device. And all the information about the devices are stored in their respective files in this particular directory. And if you want to see information about it, this is where you'll have to, come and see it. Any questions on this DU, disk usage, and DF file system? We have not gone into some advanced features like creating a file system because we do not have empty, hard disk to create a new file system. But there is a command called fdisk. Okay. Instead of running the command, let me show you the man pages for it. So this fdisk is used to create partitions and file systems on a disk. Okay. Just like when you have a new system in Windows and you put a new hard disk, it allows you to format, right? You right click on that and you go to format. Once you go to format, it allows you to select a file system, then the drive letter, then the name. Okay. So all those things which you do in Windows with respect to formatting a particular drive, creating a partition, all those can be done on obviously Unix and Linux systems also. And that command is called as fdisk. Okay. Fdisk is the command that helps us to create partitions and write or create file systems on top of that partition. And while creating those partitions and file systems, you can give a lot of options. You can define the sector size, you can define the compatibility mode. Okay. Um, you can see the list of partitions already, okay, there on that disk, so on and so forth. Okay. It allows you to wipe the partitions also. And what are cylinders and sectors? We have already learned this in our data center basic class. Okay. So what is a track? What is a sector? What is a cylinder? We have already learned this. Okay. So you see here, fdisk command even allows you to define that also. How you want to logically define the platters inside the hard disk. Okay. All that is also possible using fdisk. So very powerful command, but we be very careful while using it. Okay. One thing you will notice here is that it talks about the devices on which fdisk command can be run. And we just now saw every device is there listed under the /dev directory, /device directory. And every device is going to get a particular device name. Okay. And in order to use that particular device or get information about it, all you have to do is go into that particular directory of that particular device inside the /dev directory. Now, with respect to hard disks, we understood that the hard disks use something called as SCSI, SCSI interfaces in order to interact or read and write information into that particular hard disk. And hence all SCSI devices, all SCSI hard disks are represented as SD, okay, SD, and followed by a particular alphabet, okay, SDA, SDB, okay, so on and so forth, right? So if you have one hard disk, it will come as SDA. If you have one more hard disk, since A is already taken up, it will come as SDB, okay? And all of them will be stored under the /dev directory, okay, under root, right? Under the hard disk, you can create multiple partitions using this fdisk command, just like how you can do in Windows also. Let us suppose you have a hard disk which is of 1 terabyte in size. That means almost 1024 GB. Okay. Now you want to do half, you want to do one partition for something else, another partition for something else. So partition 1, you want it as C drive, and partition 2, you want it, let us say, as E drive. Same thing you want to do in Linux, right? It is possible. How? The partition 1 or the first partition will be called SDA, which is the SCSI disk A. First partition will be 0, or that is the whole disk. SDA 0 means you are referring to the entire disk, okay, the whole disk, no partitions. But the moment you create a partition, the first partition will be defined as SDA1. Okay, the first partition will be given an ID 1. The second partition will be given an ID 2. And each one of the partitions again will be denoted under the /dev directory as separate, devices. Okay, because you can manage and read and write each partition independently. Okay, so you want to perform certain action only on the first partition, then you, whatever command you will run it on /dev slash, instead of giving SDA, which is the whole drive, you will say /dev/SDA1. Suppose you want to do any action on the second partition, you will say whatever is the command space /dev/SDA2. Okay, like that. So you can go down to that granular level of directing or giving commands per partition also. And the way you will identify the partition is under the /dev directory. You will see that the parent disk or the bigger disk will be denoted by /SDA, and the whole disk is denoted by 0, and each partition inside that disk will be given a number associated with the same name. Okay, and this is how it's going to be displayed. Okay, so let us see some output of this fdisk command. Okay, and these are all the various types of file systems you can write using fdisk command. Okay, right. So if I just give this command fdisk, see, bad usage, which means you have to give something more to it. Fdisk space, it is asking which device. Okay, now this is one trick. What did I do? See, it is humanly impossible to remember every option of every command in Unix or Linux. Okay, there are hundreds of them. It is just impossible. You can probably remember a few commands very quickly and very easily, but every option of every command very difficult to remember. So the Linux developers are so smart that they have given us a very easy way to identify what we need to do next. Okay, if you don't remember the options of any command, no problem. You enter the command first, okay? Give a space as I did now, okay? And just press the tab key in quick succession twice. Tab, tab, okay? Tab, tab. The moment you press tab, tab, it will only tell, okay, array, you have to give something here like this. And the moment I see slash dev, it will allow me to remember, okay, now I have to give name. I have to give the name of a device. So how do I know? I know that the device starts with SD, but again, I don't remember what is the exact number. So I give whatever I remember, SD. Then again, I give tab tab. Okay. So which if tab tab is not working, that means SD is not there. Okay. In that particular device directory, SD is not there. Okay. Again, I give tab tab after dev. It is showing, okay, see here, I have SR0, then I have NVMe, okay. Then I have RHEL swap, RHEL home, RHEL root, okay. Now, why this NVMe is coming instead of SD? Because in this laptop, the hard disk that has been allocated to this particular virtual machine is not a hard disk. It is not a SCSI disk. It is an SSD. It's a solid state drive. And solid state drives are represented as NVMe. Okay, non-volatile memory, NVM, non-volatile memory. E means enumerated, non-volatile memory enumerated. So it is showing me that under the device, the I have under slash dev, I have a particular SSD called NVMe 0N1. Okay, NVMe 0N1. Okay, that's the name of the device. And then the partitions under that device are denoted as P1, P2, and P3, as you can see here, right? There is one partition on this device called P1. There is one partition called P2. Okay, and then there is one more partition called P3. Okay, so on this single SSD, three partitions have been created. Okay, so but if I want to do any action or run any command on the whole SSD, then I don't give any partition number or name. I just simply give the name of the device. Then I give space. Again, I press tab tab. Okay, then it is asking, okay, which other device you want. So I don't want to do any other device. I just want to see for this. So after giving this, I press enter. When I press enter, see what it is saying. Welcome to fdisk. Changes will remain in memory only until you decide to write them, and be careful because it is whatever you do with fdisk, like create a new partition or delete a new partition or change any partition, it is going to have impact on the data that is already there on that particular partition. Okay, so you should be very careful while running this command because it will have the capability to delete everything. So instead of deleting, I just want to see info. So info I. So I press I and see, give enter. It is asking you need info about which partition, partition 1, partition 2, or partition 3. So I say partition 1. It is giving me the info, and you see the device name associated with it, slash dev slash the NVMe device name, that means the SSD device name, then followed by P1, partition 1. Okay, then it says this partition starts from so and so sector and ends at so and so sector. Okay, so the total number of sectors it is occupying is this. And what is the size of this partition? 600 megabytes. Okay, very small partition. then what kind of a partition it is? EFI system partition. Okay, so you can get so much information about this. Now again I press I and I press the second partition, partition 2. Now it gives that wherever you see here, this partition is ending at 1230847 sector, and immediately after that the second partition is starting 1230848. You see this? So which means that on the same disk, the same SSD, when you're creating the partition, wherever the first partition ends, the second partition starts immediately after that. Wherever the second partition ends, the third partition will start immediately after that, so on and so forth. Okay. And it is showing that this is a little bit of a larger partition. It is not 600 meg, it is 1 gig in size. And this is not the system partition. Here it says EFI system, but this is a Linux file system. That means this is the one being used by the users, okay, who are logging into the system to do read and write operations, to store their files permanently and all of that. Okay. Whereas the earlier partition, partition P1, was being used by the system to write maybe configuration files, to store the booting related information, okay, all those things about the particular machine, those will be stored under the system partition. Okay. Now let us again press I and see what's there in the third partition. I press I and I press 3. Okay, and press enter. Now this is showing me the third partition, and again you see here, wherever the second partition is ending, the sector, okay, immediately after that, the very next sector, okay, the next partition is starting, and you can see that here, the sector number. All right. And this is even bigger. This is even bigger partition. This is 78 gigs. Okay, 78.4 gigs. And it shows here that it is a Linux partition only, but the type is LVM. LVM means Logical Volume Manager. Okay. Mm, Logical Volume Manager most likely is a special kind of a partition created, okay, in conjunction with multiple volumes. Okay. So we will get into the more details about this later, once we learn how to deal with multiple partitions together. Okay. Now let us see what are the other options that are available on in this fdisk utility. Okay. Then we have list. Okay, L, list. So I press L and I press enter. Then it is showing me the complete list of all the kinds of file systems that this utility supports. Okay, so you can see EFI is the system partition, then MBR, master boot record, is for Windows, then BIOS boot, Microsoft Reserve, then IBM's partition, then HP partition, HP types of file systems, then Linux file systems based on Intel x86, then file systems based on ARM, okay, which is AMD processors. So all these different kinds of partitions are there. Power PC is also from IBM. Okay, so on and so forth. Okay, so no need to get bogged down about the various details about this. Okay, you will be given what partition you have to write onto that particular, what file system you have to write on that partition will be supplied to you. That information will be given by your leader or manager, and you just have to execute that command. So don't have to worry about it. Okay, which file system to use, they will only tell. Okay, so you see this fdisk command supports a lot of partitions. Okay, a lot of file system types. Okay, now let us see some other options available here. Print partition table, P. Okay, now we see the three partitions, whatever we saw under with option I, it is showing as a summary. Okay, we see that this is a virtual disk created out of NVMe, which is an SSD. We see that each sector is of 512 bytes. Okay, sector size, again it's saying logical sector size and physical sector size are the same. Okay, 512 is to 512. Then minimum IO size. Minimum IO size means whenever you're doing any input or output operation from this particular partition, the size of each write or read operation, what it's going to be, it's going to be 512. Okay, so it is in perfect alignment with whatever is the sector size on this particular partition. And you will see later that this information, the IO size or the block size versus the sector size, plays a very important role in troubleshooting the performance of any particular storage system. Okay, extremely important piece of information. Okay, and sometimes it is the defining factor. It is the defining factor to make sure that the hard disk is performing to the maximum potential. Okay, just imagine if the sector size is 512 and I say my while creating the file system, I say my IO size, let us not keep it 512, let us keep it half. Okay, 256. Then what is going to happen? For every write operation that I have to do in a sector, I have to do two writes, isn't it? To fill that sector. Similarly, when I want to read any information from that sector, I have to do two reads. So what has happened? Just because while creating the partition, I gave a IO size, which is half the sector size, the performance of the hard disk got reduced by 50%. Okay. So it is very important for you to understand how hard disks and SSDs are logically constructed at the operating system layer in order to do troubleshooting of performance related issues in a data center. Okay, and as and when you work more with data centers, with machines, this information is going to become very handy. Okay, and I will also show you other tools. There is a tool called iometer. Okay, we use that extensively in data centers. So using iometer, you can simulate a load. Okay, instead of actually doing reads and writes onto that particular system, just to simulate a load. Okay, you can use this tool called iometer, again a free tool. Okay, a lot of good things in this world are free. Okay, including iometer, and we can use that iometer tool to simulate a load, and that is when I am going to show you. And all this we are going to do in the advanced class. Okay, not in this intermediate class. Okay, here we are just learning the basics of how to do things. All right. So we are not going to create a new partition here. We are not going to write any new file system. We are only seeing information about what is already there on that particular SSD or on that particular hard disk. Okay. Any questions until now on whatever we have learned? This will take time to digest. So after you finish the test coming Saturday, you relook at all these recordings and practice them. Okay, unless you practice these, you will not understand. Okay, before moving out of fdisk, let us see one more option, verify. Now when we use verify, you will be able to see if there are any hardware or software corruptions in that particular disk. Okay, it may happen. because these are, ultimately, electrical and electronic components, right? So they are bound to fail. Okay. When they start failing, they give certain indications. Okay. And the very first indication is bad sectors. Okay. The very first indication that an SSD or a hard disk is failing is the number of bad sectors on that particular device. Okay. So how to verify, how to see in Unix or Linux that if this particular hard disk is going to fail or is failing, you just verify, run a fdisk v command, verify on that particular partition, on that particular file system. It will automatically show you if there are any bad sectors, that means corrupted sectors on that particular hard disk or on that particular SSD, and it will be able to tell you how many of them are bad. And if you see, the number of bad sectors are much more than the total number of sectors, even if it is crossing, I would say, 10%, okay, of the total number of sectors uh, in that hard disk. That's a clear indication, that's an absolute clear indication that the hard disk is going to fail or the SSD is going to fail in the very near future. And you have to take actions to replace that hard disk. Okay. Whenever you find the number of bad sectors in a particular hard disk going beyond 10% of the total number of sectors, that's a clear indication that the hard disk or the SSD is going to fail, and you should take steps to replace that particular hard disk. Okay. Okay. Now, before we move forward, now we understood that if a hard disk is going bad, you have to replace it. Okay. But then what will happen to the data on that particular hard disk? Okay. If you replace that hard disk, the data is gone, isn't it? So what is the mechanism that we can use to copy the information that is there in that particular hard disk or SSD to somewhere else? Okay. We all know the command cp, right? Cp command. So when we use cp command, okay, what do we need? We need a source and we need a destination. That's all. Copy from here to there. Very simple. One second. Just like how you do in Windows. Control C, Control V. Exactly the same thing in Unix or Linux is done by CP, copy. Okay, CP, copy. But CP command also has various other utilities and options. Okay, and those are what we are seeing right now. You can use the CP command to create something called as an archive. You can create this, you can use the CP command to create a backup copy. Okay. You can use the CP command to copy only the contents without the permissions and metadata, which is this. Okay. You can use the CP command to copy only the attributes. Okay, do not copy the file data, just the attributes. Okay, like the chmod, rwx, the metadata of that command, when it was created, who created it. Okay, all that information. All right. So there are many other options available. So you can use the cp command to copy from one place to another place, from one place on the system to another place on the system. But what if you want to copy from one machine to another machine? Okay, then what you will do? Because see, in this particular machine you have only one SSD, and if the number of bad sectors on that SSD is going more than 10% of the total sectors, as I said, you have to replace it. Now, before replacing it, you have to copy that data. Not, but where are you going to copy? You have only one hard disk or one SSD. So you have to copy it to another machine, right? So then what command will you use? So the CP command is used to copy within the machine, okay, inside the machine only, okay. In order to copy to a different machine which is on the network, then you use a command called rsync, okay. I'm sorry. So you have to use rsync command, okay. So in rsync, you see that the source will be the current machine, okay. So you see here rsync src source, but the destination, you can see that you can specify a machine name. You see, user at so and so host colon the destination, okay. Whereas such an option was not available with CP, isn't it? So CP command is used to copy data only from one directory to another directory within the same system. Okay, very simple, just like copy paste. But when you want to do it from one machine to another machine, okay, then CP command will not work. You will have to use another command called as rsync. Okay, and rsync command will allow you to copy files from one machine to another machine, okay. So let us see how to use this command. These are some of the options that are there with rsync, okay. We use rsync extensively to perform large data migrations, okay. And there are a lot of options with rsync. Some of the options that are used a lot are, number one is this recursive. Recursive means go into the subdirectories and subfolders instead of the user typing all the path, okay. User will give only the top level directory or top level path, and whichever subdirectories or subfolders are there under that, including the files, automatically this -r option will copy all that into the destination, okay. So this is very useful. You can also use rsync to create a backup, okay. You can create a backup. Then another option that is used is this one, preserve permissions. In one of our previous classes, we understood that chmod command, using chmod command, we can modify the permissions onto a particular file, rwx, 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 okay. So along with the data, you want the permissions also to be copied as is to the destination system. You can use the -p option, okay, along with -r. You can also preserve the owners and groups when you are migrating. So, or when you are copying to another machine, this is also possible. And you can preserve the ACLs, which effectively means the permissions. ACL is a term basically used in Windows, access control list. ACL stands for access control list. There are so many other options, okay, available. As and when you use this command, you will be able to identify and appreciate, all of this. So I'm going to do all of that. We will just use this for a test purpose. So what we will do is Now we will use both the machines. Bhanu, can you please align these windows next to each? Yeah. Okay. Yes, please log in. Great. Okay. So what we are going to do in the Linux machine on the left, Bhanu. Okay, let me take control again. Wait. Okay. So first I'll identify the source directory. So I'll go to cd root. So this is my present working directory. I will do ls minus al to list what and all is there. Okay. So we see a directory called tmp. Okay. So we will use that. So I will say rsync temp. I will do recursive. That means minus r. That means whatever are the subfolders in temp, I want all of that to be copied, and I want to preserve the permissions. So minus p, and then I will give the destination where I am going to write this to. Okay. So I will write it to root at what is the IP address of the Proxmox machine? 192.168.1.35, and in this machine I want to write it under slash tmp. Okay, and I'll press enter. Now what it says, there is no root, there is no file or directory called tmp under here. Okay, so let us quickly make that directory here. So here, right, pwd, I'm in the root, so I go here. Now I do ls minus al. So there is a directory called temp, but okay, let us make a new directory. Let me say mkdir test. Okay, and I will give permissions 777 to test. Now I do ls minus al. I will be able to create it. Okay, here test is created with all the permissions, right? So now I run the rsync command. Okay. Bhanu, can you give me control, please? Yeah, thank you. Okay, I will use the rsync command, and instead of temp, I will say test. Okay, and press enter. Some issue. Why is it trying to create this? Okay, so if I have to do troubleshooting, I can go to /var/log and I can do ls. So yes, messages. So I'll say I display whatever is there in this. There is no error message here. Minus 20. Okay. Okay, I will troubleshoot this and we will do this rsync tomorrow. Okay, we will make it work. It will work. Okay, the command is there. It will work. So we'll make use of it. Maybe it's a credential issue. So we'll see how to do that. Okay, so any questions on what we have learned today? We have learned quite a few commands in Unix or Linux. Okay, so any questions? No, no problem. It may be a little overwhelming in the beginning, but as and when you practice, you will find it to be, really easy and very fun actually. Okay. Uh, I hope all of you are preparing well for the exam and evaluation test on Saturday. I have already prepared more than 100 questions, okay, for you all. It took a lot of time from my side. So I sincerely request all of you to prepare well and please do make it a point to attend the evaluation or test on Saturday for the data center basic topics. Okay. All right. Thank you so much, boys and girls. We'll see you again tomorrow. Have a good day. Bye bye.